All right, well, hello physical science students, and welcome to this video lecture that is going to go through circuit analysis for both series and parallel circuits. So the intention of this video lecture is that we're going to extend beyond more of the conceptual ideas that we have about electricity and circuits. We're really going to get down and analyze them in terms of the current in the circuit and the voltage drops that we have across components. Okay, we've done a little bit of this, but I'm going to give you a step-by-step method as to how we're going to do this for both series and parallel. Okay, so our basic steps that we're going to use. First, we're going to find what the total equivalent resistance is in that circuit. From there, we're going to redraw the circuit with that equivalent resistance. Third, we're going to find what that current in the circuit is. Remember, in series, because current only has one path to travel, current is the same throughout. And then finally, we're going to find the voltage drops across the components within that series circuit and make sure that they sum to the voltage coming out of the battery. Okay, so what I have here is a pretty simple series circuit. I have a power supply that's putting out 120 volts. That's pushing the current through, and I have 3 resistors here. So step 1, we're going to find what that equivalent resistance is in this circuit. Remember that in a series circuit, we're basically just adding up those 3 resistances. So my RT is going to equal R1 plus R2 plus R3. All right, and if I did my math right here, if we add those up, we should get 60 ohms of resistance. Okay, now I'm going to redraw the circuit. This is an important step. Okay, so if I redraw my circuit, I'm going to boil those 3 resistors that I had up here down to one that has this 60 ohm resistance. Okay, so I'm going to draw my resistor here. I still have 120 volts, and then I have 60 ohms total in that circuit. Okay, so notice that this is much simpler now than what we had up here. Now, utilizing Ohm's law, we can find what the current in that circuit actually is. So remember that Ohm's law says V is equal to IR. Well, if we're looking for current, then we are going to have I is equal to voltage divided by resistance. Now notice, in this new circuit, I know my total voltage, I know my total resistance, so this becomes a pretty easy problem. So I'm going to have the current is equal to 120 volts divided by 60 ohms, and I am going to get a current of 2 amps. All right, now this last part where we're finding the voltage drops and making sure that they equal what's coming out of our battery, we have to go back up to our original circuit because we need to find the voltage drop across this resistor, and across this resistor. Now remember, voltage drop is just a fancy phrase that we use for how much pressure or how much voltage we need to push the current through these various components. Okay, so if I'm looking at resistor 1, and I'm going to call this V1, I know that V1 is going to be equal to the current times resistor 1. If we do that math, we're going to get a value of 20 volts, okay, because I'm going to have my 2 amp current times my 10 ohms. So I get 20 volts. All right, now V2, we're doing the same process. So I'm going to have current times resistance 2, and I am going to get 75. Nope, not 75, 70. I'm going to get 70 volts. So that's my voltage drop across that second resistor. Okay? And then finally, V3 is going to be equal to current times the resistance of that third resistor, which is 15. So I'm going to have 2 times 15. That is going to equal 30 volts. Okay? And then if we add these up, my total voltage is equal to 120 volts. Okay, so there's our process for circuit analysis for series. These steps work all of the time, okay? And we're going to actually utilize similar steps when we do circuit analysis for parallel, which is on the next slide. All right, so moving on from series to parallel, I have some basic steps here. Now, the first two are very similar to series. So we're going to find the total or equivalent resistance first, and then we're going to redraw that circuit. From there, things go a little bit differently. With that redrawn circuit, we're going to be finding the current, specifically the current through the power supply. So that's going to be, and I'll draw it up here, that's going to be what we're going to call I here. And then finally, our fourth step, we are going to find the current through these different branches that we have, through these different parallel branches, because remember, in parallel, this current that comes through the battery is going to split. So this current could take this loop, the current could take this loop, or it could take this loop, okay? So we're going to have to find the current through each of these branches, but that's easy because we know that the voltage across each of these resistors or these branches is going to be equal to the 9 volts coming out of the battery. Okay, so we already know what the voltage drop across each of those resistors is. So our job in parallel is going to be to find what the current is that's flowing through here. All right, so first we are going to find our equivalent resistance. So step one. Now remember, with parallel, this is a little goofy, okay? So to find our equivalent resistance, we have to basically add up the reciprocals. So we're going to add up R1 plus the reciprocal of R2 plus the reciprocal of R3. And then once we add those up, we take the inverse of that answer. And if I did my math right here, we kind of get a goofy equivalent resistance. We're going to get a resistance of 25.7 ohms, okay? So now I'm going to redraw my circuit. I have my power supply here. I have my 1 resistor because that's representing my equivalent resistance. I still have 9 volts coming out of that power supply, and then I have 25.7 ohms over here, okay? So now step 3, we need to find the current that's going through this power supply. Okay, and again, we called that I. So, from this simple circuit, this redrawn circuit, I have a voltage and I have a resistance. So if we look at Ohm's law, V is equal to IR, well again, we are going to have I is equal to voltage divided by resistance. So, if I plug in my values, do a little math here, I'm going to get 0.35 amps, okay? Oops, and I actually wrote voltage here. This should be current, okay? So my current through the battery is 0.35 amps. So I'm actually going to rewrite that up here. So I is equal to 0.35 amps. Okay, so now step 4. We basically are going to be finding here I1, I2, and I3. So let's get a different color here, and we'll start on 4, step 4 over here. So the key here, now we're going to be taking a look at our main circuit again. So looking at this first branch to find I1, I know my resistance, I know my voltage. I know my voltage drop in this branch is 9 volts, what's coming out of the battery, okay? So I know if we're looking at V is equal to IR, well, I know this and this, so I can find what this current is equal to. So if we do that, I1 is going to be equal to V divided by R1. Do that math, we are going to get I1 equal to 0.1 and 0.1 amps. We want to be sure that we keep our units straight there. Okay, so I1 is equal to 0.1 amps. Now, I2 is going to be equal to voltage divided by R2. Plug those values in, do a little math. I am going to get 9 divided by 45. I am going to get 0.2 amps. Okay, so that is I2. Finally, I3 is going to be voltage divided by R3. So I'm going to take my 9 volts divided by 180, and I am going to get 0.05 amps. Okay, now the key here is that these three currents should sum up to I. Okay, the current that we calculated through the battery. If we add those up, okay, so take 0.1 plus 0.2 plus 0.05, we do indeed get 0.35 amps. Okay, now the key here again, just to reiterate, with parallel, that current splits right here, okay, where that first parallel branch is. Some of the current goes this way, some continues on this way, and some continues on this way. But at this point, I1, I2, and I3 meet back up to then get this 0.35 amps of current once again, okay, and that's reflected down here. So that's circuit analysis. That's breaking it down step by step. The steps that I gave you for series and parallel, okay, these steps right here, they work for every circuit. There's going to be some questions on the knowledge check that are going to ask you to do a little bit of circuit analysis. Okay, so good luck. I hope this was helpful. I hope you took good notes. Take care, physical science students. We'll see you tomorrow.